Welcome to our PostgreSQL using Microsoft Azure webinar. I am your host, Jim Staley. Happy to have you folks here. Now, I know what you're thinking, another webinar about databases, but stick with me because today we're going to talk about something truly exciting, moving from Oracle to PostgreSQL. And by the end of this, I promise you'll feel like a database migration rock star. If you've ever thought, what's fun in data migration? Well, let me tell you, it's like packing up your old house and realizing you've been hoarding way too much procedure language SQL code. So buckle up because we're about to embark on a journey where data isn't just moved, it's transformed. And don't worry, there won't be any heavy lifting from you. That's where QMigrator is for you. Let's start by introducing our panel. Our first panelist, the insightful Jared Mead. As a senior product manager within Microsoft's Azure data team, Jared's unparalleled focus on customer experience associated with database migrations to the Azure ecosystem, particularly in adopting Azure Postgres database platforms, is sure to provide us with valuable insights. The Microsoft Azure data team is unwavering in their commitment to ensuring successful customer outcomes in the notorious complex endeavor of Oracle database migrations. They are dedicated to partnering with key industry solution providers to achieve the goals associated with enterprise database migration success. Next up is Venu Gopal, our next panelist, which is the Technical Director for Data Migrations here at Quadrant Technologies. He is the leading development of our database migration tool, QMigrator. He has been in the industry doing large-scale migrations for 20 plus years and with Quadrant for over 5. Prasanth is next up, a technical director with over 20 years of experience, specializing in multi-cloud application development, delivering enterprise scale solutions tailored to customer needs across various industries. He brings deep expertise in data analytics and AI platforms to create scalable, efficient, and secure systems that drive both business and growth innovation. My name is Jim Staley. I am the Principal Director of Microsoft Solutions here at Quadrant Technologies, and I've worked directly with the Microsoft teams for the last 12 years. I'll be your host today. Welcome in. Today's quick agenda, why PostgreSQL and PostgreSQL on Azure. This will be presented by Jared, who will discuss the advantages of PostgreSQL and the benefits of running it on Azure. We'll next move into the assessment, migration planning, and migration processes. This will be presented by Venu. Vinu will give an overview of the assessment process and strategies alongside a live demo of QMigrator. Next will be performance optimization. What happens during and after migration? Prasanth will present this and demonstrate key strategies for performance optimization through the migration and post-migration process. Real-world case studies will follow this. Lastly, we will then open the floor for our Q&A session and address questions that our audience has posted in the chat window. Let's start by kicking this over to Jared to speak more on why PostgreSQL and PostgreSQL on Azure. Jared?
Thanks so much, Jim. It's great to be here, and I really appreciate the opportunity to speak with everyone. I wanted to begin by aligning us together, bringing us to discuss what we all have in common, ideally, which is we are all interested in learning what the best strategies that we can employ for migrating from Oracle to another modern data system would look like, and what are the interesting facets that are going to accompany that decision. And when we speak to many organizations, we understand that they are focusing on assessing their infrastructural environments, their ever-changing collection of business drivers, and they're considering an increasing number of decision points and facets that are going to determine their strategic priorities and their roadmap. We know that decision makers are increasingly tightening their spending, and they're always seeking efficiencies wherever possible. At the same time, they have to keep their priority and their North Star on staying competitive and investing in areas that drive innovation. So with these competing circumstances, it's easy to understand why so many are looking to use the cloud as a force multiplier for their IT needs. Whether Organizations are focusing on addressing security threats. They are looking at their evaluating software and hardware refresh budgets. They may have other budgetary constraints that they're looking at, or they all might be focusing end of life support inside their data centers. The cloud provides an infrastructure that is on demand. It offers a better total cost of ownership and provides flexibility that encourages innovation. So, migrating an Oracle system to the cloud can address several of the important aspects that we have outlined here on the slide for us. Um, I think those factors are well described here, and I won't spend too much time on them. But if we want to go into the next slide, please, we can really talk about what the organizations are evaluating when they are comparing or weighing an on-premise hosting model to a shared responsibility model that would be associated with cloud adoption. And if you consider the benefits of shifting entirely from your on-premise administration and management to a platform as a service or a database as a service cloud PaaS offering, you can see that moving your database to the cloud provides an additional set of benefits, including unified and connected data estate, as well as an expanded set of benefits above and beyond just what you are working or focusing on with your core database features. For example, we could see the many benefits of integrated management security, improved performance and intelligence, scalability, built-in tools and resources. All of these features or benefits come added as a matter of adopting a cloud-hosted model. Why don't we move to the next slide, please? Great. So hopefully we laid out some ideas that help to reinforce the benefits of using the cloud and why the cloud can offer so many advantages to organizations. Let's spend a little time reviewing why Postgres is an ideal choice for database migrations for many organizations. For one key detail, the Postgres database engine platform has been actively maintained for more than 30 years. So it's quite established. And many of the design characteristics will be familiar to database administrators coming from an Oracle background. Additionally, the core concepts involved in the underlying operational design decisions powering Postgres are straightforward, they're well documented, and they're understandable for many coming from an Oracle background. Most importantly, the Postgres codebase and the community are quite literally an open book and provide a number of avenues which allow for further exploration of the Postgres operating model. Let's move to the next slide, please. So hopefully at this point, we've established that a cloud-based platform and database as a service model can introduce significant value and enable more innovative delivery cycles. And Postgres is a proven battle-tested database for hosting your workloads that were originally on Oracle. Now, let's spend a little time reviewing the uh, the details or the similarities between Oracle and Postgres. And this is a bit of an eye chart on this slide, so I don't want to spend too much time going into these specific details, but the point that we want to make clear is that many of the architectural components of Oracle are going to share similarities in the way that the Postgres engine has been developed, and there is a linear learning curve when you're looking at how you might have constructed a design in Oracle and then how you're going to move that workload to a Postgres environment. Let's move on to the next slide, please. Excellent. Um, this is really a sphere, or let's say an encompassing circle of the benefits of why using Azure Cloud on top of as a Postgres engine in a combination provide an additional set of capabilities that are above and beyond what you find in using Postgres by itself. With the Azure enabled or Azure integrated Postgres model, you have capabilities like native AI integration. You have advanced security. We think about some of the capabilities such as high availability, and very importantly, the ability to scale as much or as little as you need depending upon your workload. Really, all of these benefits combine to make a very effective opportunity when considering what decisions you might be making. We can move on to the next slide, please. Okay, so this is really another view, or again, a summary to show how outlining the additional key benefits and features in hosting your Azure services on Azure Cloud provide benefits to you. And so we'll just quickly go through these advantages very briefly. But again, we want to reinforce that you are using the same binaries that the open source community uses, and those builds are going to be accentuated by the Azure managed patching and maintenance. But you have that guarantee that your flavor of Postgres is the same flavor and compatibility that the open source community has adopted. Another obvious feature is the scalability, resiliency, and high availability. Along with that, you have disaster-proof guarantees that ensure your mission-critical workloads are going to perform flawlessly. Flexibility is also a key asset, and that ensures that we provide the incredibly compelling cost of ownership models where hosting your operations on Azure Cloud allow you to use the license-free advantage of open source, as well as the adjustable scalability to use as the right amount of resources for your workloads. Perhaps most importantly, Microsoft and the Azure engineering team take security extremely seriously, and we provide enterprise-grade delivery for our data security and compliance. Specifically, Azure Database for Postgres has achieved a comprehensive set of national, regional, and industry-specific compliance certifications. And these certifications help you to comply with requirements that are going to govern data collection and usage, and are part of Microsoft's Trusted Cloud Foundation for security, privacy, compliance, and transparency. Next slide, please. So to put this in another way visually, we have an interconnected set of value propositions and advantages for hosting your Postgres database on Azure Cloud. This extends your capability matrix by providing a layered approach to integration with additional Azure services and capabilities. And so a key case in point would include seamless integration with Azure Analytics, machine learning, and AI platforms such as Azure AI Studio, Power BI services, and Azure OpenAI powered large language models, which can be seamlessly integrated with your Postgres workloads. Let's move on to our next slide, please. So to round out our discussion, we have an increasingly popular use case, which many customers are successfully deploying today, that provide the ability to blend generative AI and large language models together with an established database asset to provide an intelligent app platform. I'm sure all of us have thought about how can I make my database more intelligent, more powerful, and feature rich. Well, this well-architected solution design will incorporate application hosting features available on Azure, such as a Azure managed Kubernetes service. Uh, Perhaps using Azure Postgres allow you to use an inbuilt vector database for storing your data's embedding values while providing lightning fast response times. All the while ensuring these services are deployed in the most cost-effective, scalable, and secure manner. Applying these benefits from the billions of dollars of research investments that Microsoft has made means that you can make all of these features available to your organization. So at this point, I hope you're all reasonably enthused and excited about the potential opportunities available to Azure cloud hosted solutions built on Azure Postgres. So the next reasonable question is, how do I get started? Or perhaps, why haven't I started sooner? Well, let's move on to our next slide. It's no secret that Oracle migrations can be complex endeavors, which require many important, coordinated, mandatory steps involved in successfully executing an Oracle migration plan. And that is why we're so happy to partner with organizations like Quadrant who make that possible with their expertise and experience. And so to talk more about that, I'll turn it back over to the Quadrant team to talk through some of those topics.
Great, thanks, Jared. So database migrations present several key challenges that must be addressed to ensure a smooth transition. One of the primary issues is managing data type differences. So between systems, as mismatched types can lead to data corruption or even functional issues. In the same way, handling sequences and identity columns for generating unique identifiers requires careful adjustment to maintain data integrity. Migrating stored procedures for one database language, for example, procedural language SQL, to another procedural language PGSQL, adds complexity, as logic must be accurately translated to the new environment. Additionally, performance optimization is crucial since different systems require distinct tuning for efficient query execution and resource use. Another set of challenges involves the application code itself, which often needs modification to work seamlessly with the new database platform. Selecting the correct migration tools and techniques is critical for automating the managing process effectively. The data migration must be accurate, complete, and especially for those large data sets. Thorough testing and validation are essential post-migration to ensure the system functions correctly. Finally, managing data changes, new data or code added to the production system during the migration process, it does require proper integration to keep everything up to date. So let's flip over now to Venu to discuss more about this and see a live demo of QMigrator.
Thank you, Jim. Thank you for setting up the stage for what I'm going to cover. Hello, everyone. So Jim covered these migration challenges, which are important. Like when we are talking to many of the organizations, like everybody have Oracle workloads, and they want, if not all, some of that they want to migrate to Azure, PostgreSQL or PostgreSQL. So it is like main thing is this challenges that is inhibiting them. They have apprehensions like how we can migrate, right? That's what we are going to demystify today. Yeah. Next slide, please. Yeah. So what we are going to cover is we're going to first initially cover the assessment and migration plan, and then actually migration process, and then QMigrator demo. So let's get into assessment and migration plan. So part of the assessment, we need to do the discovery. We need to understand the current system architecture. What are the inventory of applications and databases that are there? What is the database role? This is all database focus centric today. So what is the database role in the current system? We need to understand that. And then we have to do some scans like database scan, code scan, those kind of things to understand how much inventory and what is the amount of code that is there and the complexity of the code, how many number of statements or how many procedures we have in the system or in the database that we need to understand. And we also have to understand, like Oracle has AWR reports, which is kind of helps in understanding the capacity utilization currently the current system has. So that is going to help. And not only just scanning and probing the systems, but we also need to understand from the business owners and SMEs how the system is working, what are their data flows, how the data is flowing, and what are their current system challenges. Why? What is the reason? What is the motive to migrate to cloud and to Postgres, right? So as we understand this, there are several considerations, migration considerations in terms of environment. What is the current environment, like whether it is a rack, there is Exadata, or regular server in the when we are migrating, what kind of connectivity it has, cloud connectivity from on-prem, and what are the database features it is currently or being used, like partitioning, any flashback, those kind of things that are currently being used. We need to evaluate, we need to understand that. And what kind of users and roles, security model that is being used, any PII data is there, right? We need to understand that. And as we are understanding the code through the discovery process, all the Oracle features that are being used, those have to be mapped, right, to Postgres features. And if at all they are not directly mapped, what are the workarounds? We need to understand that. And data types, handling the data types is very important. The data formats as well. Date formats could be a little bit different than Oracle. So we need to understand that. And most importantly, the performance. What is the current system performance benchmarks? Right, that is to start, and we need to achieve that. And what kind of growth, transaction growth and database growth that is going to have, we need to plan, we need to take that into consideration, right? So here we are looking at a architecture from a database point of view. It's not a system architecture, it is just how database is being interacted in the on-prem with the existing applications, workloads, or ETL, or any reporting systems, or any messaging systems, right? So all that has to be, when we are moving into cloud, we have several options. We need to evaluate those. For example, when application, if it is just a lift and shift, it can come as in VM. But if the goal is to have make it more microservices or very scalable, very elastic, and that could be extreme Kubernetes based architecture. But if it is in between, we do not want to manage the application, so managed service like an app service could be in between. So like that, there could be several, because cloud has several options. That is the main motive for anybody to migrate. So there are several options. We need to evaluate those options carefully and then select that. And that kind of architecture planning and target architecture we need to come up with. So, and then we need to, this is part of the assessment and migration planning. We need to have analysis and solutions we need to come up with. Like any, directly not correlated features, what are the workarounds? And anything that is there, for that we need to do POCs, any rewrites. We need to have all that carefully evaluated. So we need to evaluate and finalize those options, considering all those migration challenges, right? And then we need to have some, if at all we have to do POC, we need to bake that into the plan prior to the migration or during the migration at early stages, right? So all that has to go into the planning. And carefully, an important point, another thing is, when we have this target architecture, we also have to come up with what is the target SKUs, right? And estimate BOQ for that. We need to have that estimation, and we need to also estimate migration cost, and we had to put together as part of the decision-making process. So, we have kind of probably understood what kind of effort, how we want to do it, all that, right? That we need to put all that into migration plan, right? I mean, it's migration, if it is a large complex system, we probably cannot migrate everything at once. So now we have to break down that into phases, if that is possible. Break it down by applications and workloads, or break it down by if there are multiple databases going one database at a time, right? So that kind of work we had to do. And after breaking down into phases, each phase, again, we had to break it down by modules or workflows that we can, do our system integration test cycles that we can achieve, we can do, right? So that is you do not want to have months or few weeks of work and then go all the way to the end, right? You want to probably have a bi-weekly cycles as much as possible. You need to plan all that. So, and then we also have to plan some load testing cycles that can be started early, because that is going to understanding the load model, those kind of things might take time. But probably when we are at a good stage during of your SIT, at least 70-80% is done, we can start executing these load test cycles as well. And eventually, You can have like intermediate UAT cycles or at the end UAT and being ready for prod. Right, that kind of planning needs to go in as part of migration planning. We need to have, again, right, resource loading, how we want to gradually add the resources, onload and offload, and what kind of support we need to have during migration or UAT, and then post production. We need to plan that carefully. And production cutover plan is very important. Right, we are directly going live. We do not want to have any business impact. So having that environment prepared and doing ahead of time the data loads and doing like the change data capture, like continue to have the data synced up, and having some mock cutovers and testing is important. That has to be considered part of the migration planning. So at the end, we get the deliverables like a migration assessment report, a migration plan, and a TCO ROI analysis report. Depending upon how a customer wants, this can be all together as one single report or their individual reports, and how it is progressing between each of this. Right. So that's pretty much covers the assessment and migration plan. And we can move on to migration process itself, right? So migration process, first of the important thing is to setting up the environment, setting up the source reference environment, right? Even though we are migrating from Oracle to Postgres, here having the Oracle environment, including its applications and workloads, all right, the critical workloads that we are migrating, to have that reference environment is important. Right, and then along with that, there could be multiple target environments: development, SIT, UAT, and staging and prod. All right, means we do not have to create all these environments at once, but as we go along, we have to have those environments prepared. And the setting up the tools, so like whatever the migration tools automation tools we are using, that also has to be, we need to set them up as part of the environment preparation. And the migration process, so if you see here, we've broken down into like 3 or 4 pieces here, like storage objects migration. People also call it as schema migration. So having those tables and its dependent objects converted into the target Postgres format and converted. And then after that, we had to do the data migration and validate it, all right, and then make it database ready for any querying or connecting with the application. And then another big piece in parallel that can go is this code objects migration, where you have a lot of PL/SQL code, procedures, functions, packages, so that all have to be converted, make sure that the execution issues are not there and the functionality is working. All that we need to test it and keep it ready. And in parallel, there could be other aspects of database like security, like users and roles, or any replication things or jobs setup. Those things also we can work in parallel. While this database preparation is going on, we need to also ensure, the workload application, like data access layer changes, kind of those things have to be remediated and kept ready, right? And then once this all development is done, then we are moving into the SIT phase. So here, how we have to plan the testing phase is like we need to have the application broken down by modules or workflows, all right, so that we know we do not want to test everything at once. We need to test, like 10%, 20% at a time, right? That's where we have to define this SIT cycles, like what modules and workflows we are going to test it, and then execute them. Right, and as we see the issues, we need to address in future SIT cycles. And at some point, like when we are at 70-80% ready, we have to probably do the load testing as well. The preparation has to be started early, but we need to have that. There should be several load test cycles. Like we can start with a single user testing, but then we need to gradually increase the load workload to reach 100%, like 5%, 10%, 50%, and all. We have Prashant is going to cover a lot more on the performance optimization, so I'm not going to touch much on that. And then we need to bring it to the development and testing cycle to a stage where it is UAT ready, and we have to do those UAT cycles. These are also have to be carefully planned, and any issues we are seeing in UAT or SIT, they have to go back to the development team, has those issues fixed, and then add it into like we need to do SIT and move it. Along with that, there could be like production changes, production fixes is also there, or production releases are there. Those changes, we call it as delta changes. We need to bring that into the migration process. We need to handle them and introduce into these test cycles so that we are in sync with application production. Okay. So the migration process, this is the production cutover, the final one. So we need to, doing all the work, right? Coming to this point, having this production environment prepared well is important, right? In terms of security, network, capacity, all those things, right? So that preparation has to be done, and then we need to do initial loading and the change data capture. Change data capture is syncing the data, like ongoing data. You did your initial seeding of the data, but then you have to continuously keep it with the data that is there coming into the Oracle, the application, right? The current application that has to be, we need to keep it up to date. That is the change data capture process. And a lot of validation is needed. Sometimes we need to get to a confidence like data integrity or the data values, data format issues, that can cause issues. So a lot of validation should go in. And then we have to, where applicable, we need to do mock cutovers and failback plans as well. So because this is a new environment, parallel environment, we can give an opportunity for the end users to test it for functional and performance, right? And once that kind of preparation is done, we have to have an actual cutover plan as well, right? We have to have a good support plan, cutover plan, and we need to execute it. All right. So I think we've broken down, this assessment and migration planning and then migration process into very simple. Maybe it is looking simple, but it is not, right? We understood the complexities, challenges as well, right? So people do use tools to do this, right? Everyone, there are tools. Some are good in data migration. Some are doing data migration, but they do not do they do the initial loads, but not the change data capture. There are some code conversion tools, and some there are testing tools as such. So there are many tools specialized in that, right? But what we have done at Quadrant is we have used our migration experience, migrating at a large migrations, large database migrations. We used all that experience, and it's been about 5 years. We've been working on this migration tool, QMigrator. We packaged all these processes that can be automated into one single tool called QMigrator. So same things, or whatever the steps I mentioned, as much as possible, right? Wherever automation is possible, we have put into QMigrator. So we're going to go over that now. So with that, I do have a slide about it. I can same things, the steps that I have mentioned, like discover and assessment, migration planning process. Like, right, the part of that we have to do the code scans, AWR scans, like database scan. All right, all that the QMigrator is going to help doing that. And then there are manual steps like architecture assessment is manual, right? But it is understanding current system challenges, that is also manual. So we are wherever like there is a lot of manual work is required in terms of looking at the code and all that. Now those processes we automated as part of the assessment in the QMigrator. So at the end, we create a good assessment and migration plan so that it is good for easy for decision making. Okay, and like environment preparation, configuration, right? And even QMigrator itself has to be set up part of the environment preparation. And then later on, when we are creating different environments, right? It has a repo integration as well. So it facilitates, helps in setting up the environments, different environments, QMigrator. And the migration is an important process where we are doing the schema code conversion, data migration, and all that, right? And deploying it to different environments, part of the migration process. So all those processes are automated into the queue migrator. Okay, and validation process, part of that, there is a lot of dev testing is required to ensure that we are doing a platform change. So we need to ensure that functionally and performance wise we are meeting the goals. And partly SIT cycles also can be executed with queue migrator. All right, so that kind of validation processes we added to queue migrator. So what is happening with all this? It is we are making an efficient plan because we know exactly how they're going to be executed, and then having all this, it is going to reduce the migration time from months to weeks. And minimal disruption, because we know that these processes are going to run consistently and there is no way to miss them. So the disruption is going to be minimal, right? Yeah, everything, like we do have dashboards to show that where we are in the migration process, and every stage, every process is going to create a migration report that is going to really tell, right? We have to just look into the reports and address the issues instead of trying to create that migration process. So it helps in that way, and eventually all this is going to have a cost savings for the customer. All right, with that, I will jump into the tool demo. Okay, let me share my screen. Right, hope you are able to see my screen. Right. Right, so what do you see? This is a landing page of queue migrator tool. Here we have multiple migration projects, Oracle to Postgres migration, and a lot of we migrate not just Oracle to Postgres, but other databases to Postgres mainly, but not even from other databases to other databases. Yeah, I'm mainly going to focus on Oracle to Postgres as part of the demo. And we do have like data access layer changes, like application changes. All right, if we have time, I will cover that. How we're going to remediate the application when we are making change from Oracle to Postgres. So this is already launched. I have this tool here. So this is the project, Oracle to Postgres migration project that is there. Just refreshing. So this is the dashboard. So this dashboard is telling what are the storage objects, the table and its dependent objects, how much are they converted. We are at 100%. And code objects, right, like procedures, functions, packages, triggers, those things. At what percentage the tool has converted, or tool, and then there is probably manual remediation as well. But where we are and what else, how much more we had to done, right? So it gives that. And then the data migration, right? Did we migrate all the data, or some data is still there, right? It kinds of provides that view. And in terms of testing, right, here we define, I'll explain you later when we are covering the testing module, what is cycle 2, cycle 3 testing. But these are the development test cycles, like how much percentage of test cases we executed, and what is the success rate, right? So, and similarly, the cycle 3 testing and SIT testing, it is going to give that dashboard view. Okay, so what do we do first? We have to do set up the connections. So we have to set up source database connection and target database connection. Let me do a time check. Okay, I have about 20 minutes to cover. So once we define the connections, right, then the assessment. This assessment exists as a separate tool by itself, and it is in the batch mode. So clients can download and then just execute that. We'll get similar reports, but for demo purpose, I'm going to show through this walkthrough here. Right, we do code scan. We connect to the database again, or we do an extraction process where it is first extracts the code so that it can work offline. Once we do that, we can actually do the code scan and get the detailed estimation, code level estimation through this. Similarly, we do the AWR scan. Right here, we upload the AWR files, which could be in zip format, and then we process them so that we know what kind of capacity it is being, current utilization, and then what SKUs we need to suggest. Right, all this, whatever the things that we do part of the assessment process, we have put them, all of them comes into the report section. So these reports I'm going to walk through at a high level. So if we look at it, architecture in this client, there are multiple small servers, small databases. These all have to go into one single server. So that kind of architecture, but it could be in a complex way. I just took a simple scenario. If I go back, there are many reports here. I have all this opened. I'll just walk through here and then go through those reports one time. So this is an architecture and then AWR report that I have shown here that we can supply and process it, and then that creates a summary report, AWR summary report, and then the system challenges, current system challenges, talking to the stakeholders, we can understand that. And then because we are doing this code scan and understanding the architecture and all that, what are the migration challenges, we can document that. And this is the detailed estimation report I'm talking about. When we do the code scan, we understand how much is automatically converted and how much more work we need to do. And based upon the AWR report, we create a BOQ, right? What are the target SKUs and BOQ, we do that. And finally, we put together the migration plan, assessment and migration plan here. So let me go through all this. These are all, I have opened all of them. So let me go through that. So this is the AWR summary report, right? It processed all that. Current, there are 4 CPUs, 4 cores, but utilization is only 2, or max 2, right? And similarly, like memory. And then what is the throughput? The IOs that is being used currently. These are going to help in configuring, identifying the target SKU, right? So next, again, so we document the system challenges in terms of maintenance, scalability, all that, right? That is going to help in terms of planning. And this is based upon our code scan and all. We can put together our observations. Like we did a quantitative analysis, now we are doing qualitative analysis with our experience and putting all those challenges here. And see, this is the report that is produced based upon the database scan, right? Database code scan. So what it is telling is, for each of these objects, like procedures, there are 68 procedures, and if we had to manually do it or use the tools that are in the like an open source tools or some market tools that are in the marketplace, how much time it would take, right? I think benchmark is an open source tool that is available there, or R2PG, that is a benchmark, how much time it would take. But with our Q migrator, what is the estimate, right? So if we are seeing like 6 total estimated by going through all these ones, right? Each and every one, it's functions, sequences, everything, indexes. Considering all this, it's about 1600 hours, but we will be able to migrate with about 500 hours of work. That means 2/3 of savings by doing, right? So we are not only making this fast tracked, but we are able to make, because that consistency we are bringing in, that is required. And then we have this is the BOQ based upon AWR report and the architecture, right? What are the SKUs, we come up with that, and then what is the cost here? There is like pay as you go model, 1-year reserved instance, 3-year reserved instance. We had to give all these options. We all again divided into non-prod. What is the estimate for non-prod? Not just databases, but other things that we're going to use as part of the migration, and prod as well here. broad BOQ all has put together. So all of this, whatever we are going through, they're packaged into one single assessment migration document, planning document. So here, everything is covered again, like an executive summary. What are the business objectives and goals, the scope of the assessment, and the technologies that are being used, architecture, and the process flow, which is going to cover like what is the migration process, how it is going to look like, and what is the TCO and timeline for the migration, right? So I look at this architecture I've briefly shown, but it is attached here. The options, the considerations and options about the architecture, the database analysis and assessment, some of the reports that we have seen, they're attached here, and the migration process flow. And again, it's the same BOQ and all. So, and this is the project plan, how it is going to look like, right? So that is how the migration, the assessment is done using QMigrator. So now with that, I will go into the other modules. The next module is a code migration module. So in code migration module, right, everything works in same way. I'll kick off code objects because I'm not going to, most of the time, I'll probably run through the reports, all right? So storage of this particular process is to migrate the tables and its dependent objects. I'm not going to go over with that. So here, code objects. Code objects is an important one. Here I will explain the process. So we have to select a run number, which is established during our extraction process. The first process we start that establishes a run number, and we select that and use it for the rest of the migration processes. Here we are selecting a source connection, selecting the schema that is there, and then the target connection here, and the target schema. Object types will migrate, convert all of them. We do not have to specify pattern, but if at all we have to do only few of them, a particular object type and a pattern, we can do that. And we do check details, and then when we execute. So what it is doing is it is preparing, and it is a batch process that is happening behind the scenes. All right, that process is running asynchronously. We will see that the status in a minute. When the job starts, we should be able to see that migration status there. But I'll walk through the report. All right, that was created. Right here we can see the report. It's not created right now. That is going to take a few minutes, like about 5 to 10 minutes to run. But here we'll go through an existing report. So this is a summary where it converted the code objects. 99 of them are converted, about 14 are not, right? Those details are going to be here. So it's available in both means this particular function and procedures, right? They got converted properly and got deployed into the target environment. So here, some of them, there are few of procedures that are available in Oracle but not in Postgres. That means there could be some, syntax issues or execution issues. Those things, mainly syntax issues at this point. So those have to be addressed, right? These are not converted. So it gives that report. And in the back in the tool, right, I'll show how we can work on them. But there are other things like deployment logs. We should be able to see the deployment logs as this is working on. We haven't deployed anything, so that's why there is no deployment log. But execution logs, right? As the process is running, it provides the log, right? So we know, and the page activity logs also, like what is happening. Those also is going to be available. Right, this is going to help in terms of where we are in the process. If the process is running for several hours, right, especially data migration processes. So what happens if the code objects that did not get converted and deployed. Those ones are available in the manual conversion screen. This manual conversion screen, again, select the same run number, source schema, target schema, object type. We'll pick procedures. And we can also see the deployed ones as well, the code side by side, but let's go with the non-deployed one. So connect by level. So here we are seeing Oracle source code and Postgres source code side by side, right? So there is somewhere an issue. That's why it is not getting deployed. How do we see it? This deployment log is going to tell, right? So there is a syntax error in this particular line number 29, but based upon this, we can find it here, and we can fix it here itself, and then we should be able to save it and deploy it from here. And if we are deploying, we should see again the status, whether it is successful or any different error we have, right? So it all can be remediated from here itself. So that's, and we do have another feature, PG check. We just run all the converted code. We run the PG check. It checks the dependencies, right, and tells if there are any other errors that we need to handle it. So data migration is an important module. So here we use a tool, open source Airflow ETL. It's widely used, widely adopted by the community. We use this for scheduling our processes, and also this provides the detailed logs, and it has the retry mechanism. All good features that we are using to do our data migration process, including CDC, right? So what do we have to do? We have to first define configuration. We need to select whether we are doing an initial load or whether doing CDC load or together combination, right? We select the source connection, target connection, schema, right? If we can do all schemas, right? And then how many small tables we want to run in parallel, large tables in parallel, and what could be for large tables, how we want to chunk it and migrate it. Just a name, a configuration name we need to provide so that we can execute or use that information for validation. And pod configuration, right? Our architecture is like we run behind the scenes. It's a very scalable architecture. Where we run for each table or each chunk, we run it in a pod. So what is that pod configuration, right? So, and data load type, whether it is default or we can use the other tools if needed behind the scenes. So we have, I mean, some of this are just a suggestive. It starts the migration process using this information, but it has the adoption, self-adoption, based upon how it is going. It kind of adjusts itself and then runs the process. Okay. So, and sometimes we can create the configuration and we can execute, coming here, we can execute, and we can monitor those pods from here, pods management. We can run the data compare process, right? We can, this is all the tool that I have shown is all based upon the DAGs. Those DAGs we can download and upload, making some changes. So all those good features are there. But I'm not going to spend time on that. I'll directly go into some reports that we create as part of the data migration. So when we start a data migration process, the first thing it does is it creates this pre-validation report. The pre-validation reports is basically ensures that the tables that are there in the source are there in the target, right? That is the basic, and then the data types are matching in the format that we are expecting, and the columns are there. Everything is those kind of checks. It does the pre-validation report, and the post-validation report is like we run the data migration, right? And we have to validate the row counts. So it does that. And once that is done, then there are some deployment like indexes creation, constraints creation. Those kind of activities also happens. We do not have to, that process runs itself. We do not have to manually do anything, right? It is a continuous process. Once we kick off the process, all these pre-validations, data migration, and then post-data migration deployment, all that happens. And then this complete validation report is also created. Let's go through that report. So it is breaking down by schema and objects. How many are there in source and target, right? At a summary level, it is showing that, and at a detail level, whether they are available in both, it is giving that breakdown. Tables, table column counts, whether all are matching or some of them are missing. Table row counts. Right here we see some tables have to be yet to be migrated. Primary keys, unique constraints, foreign keys, not null, default, check constraints, indexes, data types. So this every check that we have to do it, right? There is no point in doing this outside. That is going to take a lot of effort. All we have to do is kick off the process, and we have to focus on whether it is done right or not. So that's the data migration module, which is important that we covered. So we do have a deployment module. Deployment module covers we can deploy, but I was talking about this delta process, right? The delta process is what are the changes that are happening, right? The changes that are happening in the production. So we have the source baseline code, and what is the current code that changes. We compare it, understand what are those changes, and those changes we need to integrate into the target, right? So that is our delta process, and part of that, it creates the delta files. Let's see. So for example, here, so it created a file showing the differences between the baseline and the current code, and those changes, part of the delta process, gets integrated into the target current, and we can see those code differences also. And we can also have the comparison between source and target as well, right? So it takes care of all that. And we do have testing. Testing is an important module. We have several ways to capture the workload. So this workload is captured and then converted into test cases, and those test cases have to be executed. That is workload, test case upload, reports, SIT, test case, data migration. One second. So I'll go through how the test reports at this moment. I'm not running out of time, already short. So I'll just walk through, instead of how we are executing the test cases, I'll walk through the test reports. All right, here we can see cycle 2. The cycle 2 is basically making sure that execution is happening correctly or not. All right, so if I open that, so here many of this, all right, all the procs that are executed with the statements, and there are one of them failed but others got successful, right? So, and then the cycle 3 is basically we execute the same both on the source environment and the target environment, and then it compares the data, right, the results, and as well as the actual database changes that are happening on the source side and the target side. It compares that, and it either passes or fails. If it is failing, then it will create we can do a debug. The debug process is going to tell exactly which place, like I'll open that report and I'll show you how that looks, where which place is the error potential issue. And right here, a simple proc, right? The first statement is here, and then we are tracking the variables and checking any value changes, and there are some value changes, they are not matched. And by the time it executes the second operation, that itself is going to go wrong because the intermediate values also itself is different. So we know, even though if it is having like 10, 15, 20 statements, which statement we are started having a mismatch, it helps. This kind of debug report helps, right? So developers doesn't have to spend time identifying the issue. They need to spend time in resolving the issue. And we can execute the SIT cycles in the similar way. And we have a DBA module. DBA module handles that, how we need to implement users and roles, permissions, and Postgres. This identifying the bloating and taking care is very important. And we can execute health check reports. There could be sample reports here, some roles and users, and the sample PG metrics report is here. I'm not going to go through it, but they're all been here in this tool. And we can execute the SQL statements from here. And then the performance tuning is another module where this is during the load test and even post migration. Also, all these activities, like we can do full table scans, we can identify the full table scans, long running queries, high CPU consuming queries, where is the vacuums are happening, bloating is happening that we need to do vacuum analyze, and duplicate indexes, and identifying explain, right? Log explain is basically where, like in a large procedure, where are we having the issues, like which statement is probably causing more time. Right? If you have that explain plan, that helps. It will actually identify that. I'll go through that report. That is very important. And this table partitioning strategy, like how we can optimize, where are the large tables, and what are the candidates for partitioning, and how we can partition. It is going to help in identifying that. Right? Let's see any reports we have here. So I was telling that this is important report. Explain plan. So here you can look at it. So this is one procedure execution. In one procedure execution, right, it captured the statements that got executed. And then for each statement, you can see the plan. So these plans, we can see which plan is taking more time, and we can focus on that, right? So means the way we envisioned is we have to spend time on not identifying the problem. We have to spend time in addressing the problem. So that's our goal, and we have to do the database migrations, not like as a database upgrade, not really like spending a lot of time. Eventually we'll get there. It's probably just a weekend time. We should be able to migrate a database. We'll get there. So that finishes the demo part. I think I'll cover one more slide and hand over back. So I'm stop sharing my screen now. Hello, are you there?
Vinny, did you have one more slide?
Yeah, sorry. I was trying to find, I was at some point, I was thinking that I was booted out because I might have closed that screen share or something.
No, we still got you. You want to do your next slide and then we can move forward?
Yeah, that's right. That's right. Yeah, just get me the next slide and I'll finish my presentation. All right. So this is QMigrator metrics, right? What kind of data migration we have done? We have done like very large scale, like migrating terabytes of data, 10 terabytes of data in a day, right? We have a large source database and then high configuration target, and then we have enough network connectivity at 10 Gbps. So we have given enough capacity for the migration cluster, and we are able to achieve this high throughput migration. And similarly, at a code migration level, like thousands of procedures, like here you can see 220 packages, 11,000 procedures. So much code we have converted and tested through QMigrator. So yeah, with that, I'm happy to answer the questions later, but I'll end my demo here. Thank you. Back to you, Jim.
Fantastic. Thanks for that informative demonstration of QMigrator, Vinu, and how it can help with seamless migrations from the planning stage really to the full migration. So next up, we'll post Prasant with migration performance optimization. You know, what really happens during and after the migration. And we'll pass the stage over to Prasant.
Thanks, Jim. Now that we have seen a comprehensive approach to the overall PostgreSQL migration, we will do a deep dive into the performance engineering aspects. The approach to performance engineering for such large-scale complex migrations starts with identifying the load module. What is the load model? So basically, it's replicating the production load based on the number of users that are using the applications in the production and what are the critical workloads that they're using. We would like to mimic or copy the similar workload within the load test environment. So such setting up these performance environment is quite critical in order to analyze how the application is behaving. So generating the transition reports from the database or application insights, as well as what is the total sales that's done in a day. So for example, if you have certain modules like financial module where we are performing certain sales transactions, now this becomes a critical workload. Now these critical workloads, when executed multiple times within a day or within a time period, we need to analyze what is the peak load time across. So this can be a peak month of the year, peak day of the week, or peak hour of the day. So depending on that, we can identify the load pattern. So it's very critical for us to understand the load model based on the number of user sessions, what are the critical modules, and then what are the core transactions which would affect the overall performance of our application as well as the migration. Coming to the execution of the load test. Now, once the load model is prepared, it is important for us to create a similar environment which is close to the production. And then we do the load test to analyze the 90th percentile, the 95th percentile, and the 99th percentile, etc., depending on the business requirements. So we need to identify the overall response times of the application and categorize them into what would be a kind of a 5-second latency or 10 seconds accordingly. And then it should follow the business requirements. Now, once that is done, we would try to understand what is the overall time taken for these transactions. What's the actual transaction time versus the achieved transaction time. Now, once this analysis is done, we even want to look into the failed transactions and how to monitor them and what kind of fine-tuning that is required in order to enhance the performance of the applications. Then the critical insights would be to how, what the areas that we should monitor. So let's assume that we have identified our core problem as the response time is quite high. Now we need to identify whether it's on the application side or the database side or the networking side. So for that, we have a lot of monitoring tools which we can use. And App Insights would really help us in understanding how the application is behaving, and then the PG stat statements on the database point of view. We can even enable login analytics, and Azure troubleshooting guides should support us to understand what are the core Azure resources and how we can identify the logs based on that. And also the index tuning recommendations. How do we fine tune for better performance? And coming to what exactly should we monitor? So we should understand what is the CPU usage, what are the workloads that are taking more time, what are the critical transactions which are getting either locked, or what are the blocking transactions, and then how the connection pools are behaving, how optimal is our PG bouncer settings. Now we need to analyze the vacuum and bloats across the tables, and what's the network latency, and what are the core methods or processes which are taking more time to execute, which are impacting the overall performance. So coming to the critical aspect of areas like database fine tuning, now that we have identified the problem areas, fine tuning of databases have a lot of parameters or server parameters like max worker processes, shared buffer size, or effective cache size, etc., which needs to be fine tuned. It can involve certain procedure fine tuning, the partitions, caching, index tuning, and even connection pooling. So the more number of active connection pools are present, it's going to impact the CPU usage. So hence, it's very important for us to understand how the connection pooling is behaving. And coming to the application side, how the JavaScript, the HTML files are configured, and how can we reduce the load times, and how can we enhance the load balancing, scaling of the applications, and even asynchronous processing of the calls and the methods is quite important in order to understand the overall application performance. Similarly, on the networking side, we need to understand what are the kind of latencies, or is there enough bandwidth between the calls, between the VNet or subnet access, and ensure that there is no latency and there is enough response time in order to ensure overall performance and the migration efficiency. So Azure Monitor is a standard monitoring tool which helps us in understanding the core metrics like CPU usage, memory, disk I/O, and network usage, the query performance insights, and what are the long-running queries, who has triggered these queries, etc. And we can even set up the alerts based on these custom thresholds for resource consumption and automatic scaling based on the usage trends. Query store performance impacts a lot because all the queries that we generate get stored into the query store. So capturing the queries, the long running ones, and the execution plans, and understanding the statistics is quite important to improve the overall performance of the migration. So coming to the automated maintenance, we do have a vacuum and analyze. So they play a very important role in the overall performance. So vacuum generally reclaims the storage occupied by dead tuples, and vacuum and analyze are critical to maintain the PostgreSQL performance and stability. So vacuum reclaims the space and prevents the transaction ID wraparound, while analyze updates the statistics crucial for the query planning. Regularly, we need to monitor vacuum either manually or through auto vacuum, and which helps us to ensure that the database remains quite efficient and performant. Along with that, we do have automatic backups with point in time restore for up to 35 days. We even have updates and patches which we should take care. And Azure Advisor would generate recommendations for us based on the CPU usage and high consumption of connection pools, etc. And this would help us in cost saving and overall performance improvement. Now let's drill down into a couple of the real world case studies that we have successfully implemented using QMigrator. So Ceylon Biscuits is a rapidly growing manufacturer in the PAC region who were aiming to migrate from the Oracle Cloud into the Southeast Asia, and they sought the cost optimization and a swift transition into the another cloud platform. So the legacy Oracle databases are incurring a lot of cost, and they were having some issues in terms of scalability, which is increasing the latency. So Quadrant team redesigned the databases and aggregated them together in order to improve the overall performance, to reduce the costs. We use QMigrator to perform the migration, and the redesign of the critical applications like inventory, sales, really consolidated the PostgreSQL schemas for better performance. Overall, there is a significant reduction in the license cost, close to 40%, and around 50% of reduction in migration effort, and in turn cost benefit. So overall database migration just took 8 weeks, which really help the business to achieve their milestones and realign their strategy and improve the scalability on the cloud. Similar use case, we have a healthcare conglomerate who has tried to move all their on-premise assets into the cloud. So where their mission critical application, the hospital management system, which was running on a legacy code and facing certain scalability and maintainability issues, was effectively analyzed. So we did a detailed assessment, and quadrant engineers and architects really shared the target architecture, timeline, and cost, and we used Migrate to perform the migration. The application was migrated from on-premise. The entire data center was actually migrated to cloud, and we converted the data access layers via the automation for compatibility with Azure PostgreSQL, and around 80 plus interfacing apps and services were migrated to Azure. This overall resulted in a 30% cost saving with Azure PostgreSQL, and scalability and reliability really increased, and overall modernization roadmap was set for the customer, reducing the manpower to maintain the data center. I think these were the critical insights with respect to the core enterprise scale migrations using Migrator. And over to you, Jim. Thank you.
All right. So thanks, Prasanth. We appreciate that. Next up, do we have the slide for the free assessment? So let me talk on the free assessment while we are trying to locate that. So what we're offering to our group that has joined the call is a free assessment offering using Migrator, one-on-one sessions. And the offering would basically be initial consultation, environmental assessment, where we would do some data collection and analysis, migration strategy recommendations, and then a demonstration of Migrator in action, utilizing your data and whatever your needs are that we've uncovered during that initial consultation, and then sort of a live demonstration of the sample migration from Oracle to PostgreSQL, highlighting the key features like schema conversion, data migration and testing, post-migration plan, and final reports and next steps. So we would like to offer that to all of the folks that showed up today. And if you could scroll my information across the bottom, you guys can contact me direct through this information here. And while they're doing that, let's go to some common questions that are based around some of the information we heard today. So, and I'll put this out to the panel. Some common challenges any databases to any databases have. What would those look like, and what would those be? Vinu or Prasanth, would you guys like to answer that?
Bring it up. Bring me up. So yeah, database migration, right? Means as that's a whole. I went through all the most of the slides, and I have shown in the Migrator. At the conceptual wise, they're easy. Like we understand what we need to do, but right. I mean, it could be some particular code, feature that is being used. That whether that particular how we want to address it. Or it could be like an instance, like for example, like we have a Oracle materialized views, instant refreshes. That is not directly supported in Postgres. So how do we have a workaround? Here, the scenario is like, you have two databases. The change is happening in one database, and that is happening, that data is showing instantaneously in the other database, right? Through materialized view instant refresh feature of Oracle database. So that's very important. Like this is a centralized database, and we need to have that data, shown in other databases. So same thing, to achieve that, we have used a replication process. All right. And replication process, even though logical replication has some issues, we have put another checks and balances, how to ensure that if at all replication process fails, how we can resolve that without impacting the end user, right? That kind of solutions. So every migration, every database migration have its own challenges, even though migration processes are they're kind of fixed, or they're not there is not much differently we can do. Everybody does in the same way, but still it is we need to understand it. Every migration might have its own challenges, and we need to understand that and have a solution for that.
All right, very good, Vinny. Thanks for that. What about advantages of Postgres over Oracle?
Do you want to take that, Jared?
Sure. I think there is the obvious benefit around the licensing differences. Oracle can obviously include some significant cost to license the product, and licensing can be complex. Postgres is completely open source. It is a community-based platform that provides many enterprise-grade battle-tested capabilities that are as good, or in some cases, we could argue better than what Postgres or than what Oracle is doing today. The other differences may be that the Postgres environment, when it is hosted in the cloud, for example, on Azure, provides a lot of native integrations with other Azure or other cloud services. One of the key characteristics of Azure Postgres is the integrated security context, or the capabilities that allow you to use, for example, Azure Entra security natively integrating into your Azure data plane control. So you simplify your security context and you streamline that across your application and your database context, which is a very powerful benefit. The additional benefit to a, let's say, cloud hosted Azure Postgres environment would be the automated patching and maintenance. The concern that you don't have to continuously refresh your upgrade or your patch schedules, that is a feature that comes as part of the Azure Postgres service, which could be another really important benefit to customers. And then finally, the topic that we just covered in some of the slides that I was highlighting is the integration with the next generation AI capabilities or large language model features that we are now providing as a built-in service within Postgres that allows you to call your large language models directly within the database, which is extremely powerful, opens up a whole new suite of offerings, and really pushes the envelope on what you can do in today's development environment. So some great highlights for Azure Postgres.
Fantastic. Thanks, Jared. So with the need to identify the size of data types and its equivalent data type in specific targeted databases, how important is correct data type mapping and typecasting?
Okay. Yeah, let me take that. That's very important. That's a very first step in the process, identifying the data mapping. I mean, Oracle has wide data types and Postgres has very narrow data types, means it's very precise. So that we need to make sure that, for example, numeric number, Oracle number can handle many, it handles like different precision and scales, right? And Postgres by default, it handles a lot of precision and scale. But when you are migrating, if you're bringing it, if you do not define it, it is not going to bring the number format correctly. Like for example, if it is there as like 10.4, it's a number in Oracle, but we define as 10.4. And even though there are no 4 digits at the end, Postgres is going to put that, add those extra 3 zeros, right? That kind of data issues are there, right? We need to ensure that we have to give the proper scale, and then make sure that part of the migration we are giving the converting into a right format and storing it, so that we do not see those data issues. And another example is date. Like Oracle stores data in certain format and Postgres stores in another format. And it is important is how the application is using that date. So we always have to ensure that we are giving the date in the format that application is expecting. All right. So those things we need to understand and do the mappings properly.
Okay, makes sense. It looks like we've got, thanks Vinu for that. Shandan has a question. How does QMigrator handle application side changes as part of DB migrations?
Yep, good question. Thank you. Right, means though we are database specific, we need to understand and address the application changes and the workload impacts because we are doing the database platform change. Usually, it is limited to like data access layer, right? Or sometimes it is more than that. There is a dynamic SQL. The SQL code is written in the application itself. Good thing is we address that. We know that, right? That is very important. And then similarly, how our database code conversion process works, this DAL layer or the dynamic SQL in the application, we just give that, we export that whole package project into our tool, and then the tool can convert dynamic SQL and as well as data access layer changes. Data access layer changes being what are the Oracle packages it was using. Now it has to replace with Postgres packages. And data types. There are data types are not exactly same, so we have to convert that. And how we are handling the result set. Like Oracle has both output and in-out parameters, but Postgres always is in-out, input-output parameter. So how do we address that? So we have to consider all those scenarios. We considered all those scenarios, and already our QMigrator application migration path handles that. Thanks for that question.
Thanks, Vinny. Appreciate that. So we know there are two types of packages used in Oracle. One obviously is user-defined and then system-defined. How do we migrate packages like that in Oracle?
Sure. Again, one more good question there. So user-defined packages, the concept of package is you're packaging some common procedures and functions and to have the shared variables to use it, right? So how we want to address it. So Postgres doesn't have that package concept, it's Postgres. So we had to split that functionality. And if at all there are any common parameters, we need to duplicate that parameters into its own local variables. And then we have to have a mechanism to pass that information from one procedure call to another procedure call, those parameters. That's how you address it. There could be scenarios, it could be handled in different way. Maybe like you can have a temp table, store some data in the temp table and use that temp table there, right? That could be another solution. So there are multiple ways to handle it. QMigrator handles for most part, and some of that have to be manually remediated. And your second part of the question is how to handle the system packages. The system packages is basically, Oracle provides it, and they are available as part of like a functions, right? So we have to have an equivalent functions coded in the in Postgres, right? There are extensions which provide some of that, but we do our own user-defined functions to address those Oracle system packages.
All right, very good. Thanks, Vinny. One more question. Obviously security is a big hot button for folks, and with PostgreSQL, what sort of flexibility and transparency do they offer, and what are the security features that are offered with that?
So it has, like Jared talked about it a lot, like Azure, having this Postgres on a managed service like Azure, like it has an integration with Entra, and then inbuilt like the protocol. There is a transport data encryption TDE protocol it uses, right? And then there are, it has the row level security, and it uses the encryption mechanisms like SHA 256, all that, right? Widely, like this you can have a row level implementation of data if you want to hide it from some users, you can do that. right? That is at a database level. But at a platform level, I'm sure Azure handles that in a better way than just being in on-prem.
All right.
Yeah, just to add to that, I think there are
Yep.
over 50 certifications that we have achieved with Azure Postgres and the Azure platform. So we are addressing GDPR, the Sarbanes-Oxley requirements. There are HIPAA certifications. There are ISO host of certifications that we have achieved, so that we are ensuring your workloads are secure and safe.
All right, thanks, Jared. So today, guys, we covered everything from my PostgreSQL as a strategic choice for your database migration, using the tools like QMigrator and optimization techniques to ensure seamless post-migration performance. We also shared some real-world cases, case studies highlighting the impacts of these migrations and how they can have an impact on your organization. So as far as next steps, for those ready to get started, don't forget about our free assessment I mentioned earlier. I'll go ahead and send out a one-pager on that. We'd love to bring you folks into that and show you more about QMigrator in a one-on-one session. It's a great way to evaluate your current environment and map out a tailored migration strategy. So we encourage you to take advantage of this opportunity. If you have any additional questions or want more detailed guidance in any of the topics we discussed, feel free to reach out. You see the email that's scrolling across the bottom of the presentation. And I want to thank our panel of guests today from both Microsoft and Quadrant. We hope you're inspired to take the next steps in your migration process, whether you're looking to optimize, modernize, or scale your databases. We support you through every phase of your journey. And from all of us here at Microsoft and Quadrant Technologies, thank you for joining us.
Thanks.
Thank you. Thank you, folks.